Hello, today we're going to look at part 2 of our counting sequence, and we're going to be looking at combinations today. Combinations as opposed to permutations. Let's take a look at what that means. A combination is an arrangement of objects, just like a permutation is, but in this case the order of the object is not important. You can see that the formula looks similar to the permutation formula. You still have n, the number of objects available at the beginning. You still have r, the number of objects you want to order, but there happens to be this extra r in the denominator, r factorial. Let's see where that comes from. Really, a combination is just a permutation, but since order doesn't matter, we realize we have several things that have been repeated over and over again. So it's a permutation with repetitions. And as we remember from other permutations, if we have repetitions in our list, we need to divide them out. So when we divide that out, the formula simplifies to the combination formula. Notice r factorial is the repetitions in the denominator. This part, n over n minus r factorial, that is the permutation part. Let's see it in action. Here we're going to look at a preliminary heat that has 10 runners in it, where the top 3 runners will advance to the next round. How many ways can this happen? Now, in this situation, we are not talking about a first place, second place, third place winner. This is just a heat. It really doesn't matter where you finish as long as you're in the top 3. You will all advance. So in this case, order is not important, and that makes this a combination. So what we're going to do is we have to identify our n and r, our total, and how many groups we want. We have 10 runners available in this heat, but only the top 3 will advance. So that's 3. We'll fill in the blanks in our formula. 10 factorial over 3 factorial and 10 minus 3 factorial. Again, we'll simplify the parentheses to make that 7 factorial, but most important, recognize there are 2 items in the denominator. So if I write all that out factorial wise, you can see 10 factorial in the numerator. In the denominator, you have your 321 and your 7654321. But just like before with permutations, you will get quite a few numbers that will eliminate. So in this case, we have 720, the numerator, divided by 6 in the denominator. It ends up there are 6 different ways to repeat, which gives us a total of 120. Do you want to try this one on your own? Alright, so a principal is going to ask a class of 25 students for 4 volunteers. How many groups can volunteer? Now, in this situation, he doesn't really care what the volunteers are doing. There's not one volunteer that's more important than another volunteer. All 4 are going to get a chance to volunteer and more than likely get to leave class for a few minutes. So, order is not important. As long as you're picked in those 4, you're good. So once again, a combination is what we'll be using, and we'll have to spend special attention to divide out the repetition. In this case, there are 25 students available, and there are 4 volunteers that we need. So 25 factorial over 4 factorial, 21 factorial. And as before, you're going to get that group of numbers from 21 down that is going to eliminate. So we've got 303,600 divided by 24, or 12,650. Alright, since we've previously talked about permutations, and now we've talked about combinations, take a few moments to see if you can figure out which of these situations are a permutation and which of these situations are a combination. Excellent. Let's see this first one. The first one is a permutation. You are electing a president and a secretary. There's definitely a difference between the president and the secretary. They are 2 distinct and unique, so order is important. Super smoothie would be a combination. Since you're going to throw that in the blender anyways, it doesn't matter what order they're in, so you can choose any of those 3 ingredients. This one may have been tricky because it seems like you're doing an election like the first one. However, those 4 students don't have any special position that they'll hold. So they are really just a committee, and it doesn't matter as long as you're on that committee, just like as long as you volunteered. So that is definitely a combination of 25, choose 4. And finally, the last one is actually a permutation. Even though it uses the word combination in the problem, we know that these letters cannot be repeated. There will be no repetition here. This is a permutation. That's actually one of the unfortunate things about what we call a combination lock is in mathematical terms, it's actually a permutation lock. If you like, take a few moments on your own as well to go ahead and evaluate these. And here are your answers.